Professor Monty, and let's look at interval notation and domains. Okay, so recall the domain is the set of all numbers, typically x values, where the function is defined. Okay, so two main things to look out for. One, the denominator can't equal 0. Any values that make the denominator 0 we have to throw out. We can't use those because it's undefined in the function. Two, values under square roots must be non-negative. Now, non-negative greater than or equal to 0, so positive or 0. So think about it. If I have, say, the square root of -4, that's not a real number. It's an imaginary or complex number. You may or may not have gotten to those yet, but it's not a real number, so it's not in the domain. All right, so let's look at some examples. I've got my first function, f of x is x minus 3 over x minus 2. I'm trying to find the domain. I don't have to worry about the top. If x is equal to 3, for instance, I get 0 on the top, and that's okay. 0 divided by some non-zero number is fine. It's just equal to 0. But the bottom can't be 0. If the denominator is 0, say I get a 2, I'll have -1 over 0. That's undefined. So that value wouldn't be in the domain. So I look at the denominator. I'm thinking this. Oh, the denominator can't equal 0. So x minus 2 can't equal 0. So when I add 2 to both sides, I say, oh, x can't equal 2. It can be anything else. If I look at a number line, I've got 2 here. It can be anything less. It can be anything greater. It just can't be that 2 right there. So in interval notation, I would write that as the left side, negative infinity to 2, don't include the 2, union or anything on the right side of 2, 2 to infinity. Notice it's the whole number line except that value of 2. All right, a couple more examples. I have a square root this time in the g of x function. G of x is the square root of 4x minus 6. Well, whatever this 4x minus 6 is can't be negative. So that 4x minus 6 must be greater than or equal to 0, or else I get a complex number. I get a number that's not a real number. So those values wouldn't be in the domain. So now I just solve this. Add 6 to both sides. 4x greater than or equal to 6 divided by 4. X greater than or equal to that reduces to 3/2. That's my answer. So in interval notation, it's going to be, we'll put it right here, it's bracket 3/2 since I have the equals, all the way to infinity. Graphically, if you wanted to see that, I've got my 3/2. It's anything greater than or equal to that. This one, I put it with a circle, but oftentimes we put it with parentheses like we did here. So 3/2 to infinity, that's my domain. Any values in there, I'll get a real number. Any values not in there, I won't get a real number for g of x. And then h of x, this one's a little tricky, because remember we said values under square roots must be non-negative. I can't take the square root of a negative number and get a real number. But I can take the cubed root of a negative, and that's just going to be a negative number. So these are legal. Anytime you have a third root, you're okay. And in fact, you can go up as far as you want to. As long as this is an odd root, we can have negatives underneath. That's okay. If it's an even root, square root, fourth root, sixth root, I still can't have negatives under there. But if it's an odd root, it's okay. This one is actually all real numbers. Interval notation, you would just put the whole number on. All right, so that one's a little bit tricky, but there's only two things to look out for. If you have a fraction with x's in the bottom, that denominator can't equal 0. Just figure out what values make the denominator 0, take those out of the number line. If you have a square root or any even root, whatever's under that root has to be greater than or equal to 0. Solve that, that's going to give you your answer. Odd roots, no restrictions. Your domain's all real numbers.